Solution of linear systems by matrices. You have already learned two methods for solving systems of linear equations, the substitution method and the elimination method. Now you will learn the third method. In this method, you will use the inverse matrix. Before you work through this video, you will need to know how to find the inverse of a 2x2 matrix. If necessary, you should refer to the following video, which covers this topic. Thanks for watching this video, and don't forget to like, subscribe to the channel and activate the notifications. It's very important to the continuity of this channel. A matrix equation is an equation in which a variable stands for a matrix. We are interested in equations written as follows. Don't forget, we are talking about matrices. So, A, B, and X are matrices. If we are dealing with numbers, the solution would be very simple. We divide both sides by A to get the X value. But there is no concept of dividing by a matrix. But we can multiply by an inverse, which achieves the same thing. To solve the equation for X, multiply both sides of the equation by inverse of A on the left. And we know that matrix A multiplied by its inverse gives the identity matrix. We also know that multiplying any matrix by the identity matrix results in the matrix itself. So we don't need to write the identity matrix to care to get the multiplications correct, because with matrices the order of multiplication matters. A times B is almost never equal to B times A. The elements of matrix X are the solution to the given matrix equation. Let's see how it works. Given the matrices A and B, solve the equation. We need to calculate the inverse of matrix A. To get the matrix X, we multiply the inverse of A by matrix B. The elements of matrix X are the solution to the given matrix equation. A system of linear equations can be written in matrix form using a coefficient matrix, a matrix of variables, and a matrix of constants. Consider the system. The coefficient matrix can be formed by aligning the coefficients of the variables of each equation in a row. Then, the coefficient matrix for the system is the following 2x2 matrix. The variables we have are X and Y. So we can write the variables matrix as a matrix column 2x1. On the right side of the equality, we have the constant terms of the equations, 27 and 16. The two numbers in that order correspond to the first and second equations, and therefore take the places at the first and the second rows in the constant matrix. So the matrix becomes a 2x1 matrix. We have just written the system as a matrix equation A times X equals B. The matrix A is the coefficient matrix, X is the matrix of variables, and B is the matrix of constants. To solve this equation, we multiply the inverse of matrix A by matrix B. The first step is to find the inverse of matrix A. We need to calculate the inverse of matrix A. First, I will simplify the determinant. 2 times 3 minus 7 times 5 is negative 29. To get the matrix X, we multiply the inverse of A by matrix B. I prefer to multiply the matrices first, and then perform the scalar multiplication. The elements of matrix X are the solution to the given matrix equation. Therefore, x equals 2, y equals 3 is the solution of the simultaneous equations. Solve the simultaneous equations. Write the system as a matrix equation A times x equals b. The matrix A is the coefficient matrix. X is the matrix of variables. B is the matrix of constants. To solve this equation, we multiply the inverse of matrix A by matrix B. Let's find the inverse of matrix A. To get the matrix X, we multiply the inverse of A by matrix B. X equals 2, y equals 1 is the solution of the simultaneous equations. Pay attention in this word problem. Let S be the hours in a single engine and T hours in a twin engine. The pilot has 200 hours of flight time in single-engine airplanes and twin-engine airplanes. So S plus T equals 200. Renting a single-engine airplane costs $60 per hour, and renting a twin-engine airplane costs $240 per hour. The pilot has spent $21,000 on airplane rentals, so 60S plus 240T equals $21,000. We get a system of linear equations. Write the system as a matrix equation A times x equals b. Let's find the inverse of matrix A. Multiply the inverse of matrix A by matrix B. The pilot has flown 150 hours in single-engine airplanes and 50 hours in twin-engine airplanes.